Manager for the ABB NEMA division. Mechanically speaking, in order for an electric motor to run smoothly and properly, it needs lubrication. In other words, some bearings need to be greased periodically during their life cycle. And that is our subject we will cover today, motor lubrication. Joining me today is Ed Hugg. Ed is the R&D Mechanical Engineering Manager who has been with ABB for 12 years and has a wealth of knowledge in this area. Thanks for joining us today, Ed.
Pleasure to be here, Mac. Thanks for having me.
Motor lubrication. This is an important issue, especially when performing proper motor maintenance, and it directly affects the life of the bearings. I get a lot of questions in my classes on this, not so much on how to grease a motor, but questions about the types of grease, incompatible greases, how much and how often do you grease a motor, and open bearings versus sealed for life bearings. So let's begin with the grease itself and the different types of grease we deal with.
Great questions. Generally speaking, grease is comprised of three main components: a thickener, oil, and additives. The thickener keeps grease in place and holds the oil. In some ways, the thickener can be compared to a sponge soaked full of oil. As the bearing rotates, the thickener is worked, releasing the oil to lubricate the surrounding surfaces. Additives are included for various reasons, such as mitigate extreme pressure conditions or to reduce oxidation for increased longevity. Different greases service different applications. Bowdle Reliance motors standardize on Mobile Polyrex EM. This is a polyurea thickened grease combined with high-quality mineral oil, yielding excellent performance and life across most electric motor operating speeds and temperatures. In exceptionally high ambient conditions, a high-temperature grease is used, such as Dow Corning 44. DC44's lithium soap with silicone oil can handle the extreme temperatures of ovens, kilns, and such. When Bowdle Reliance motors are used in extreme cold conditions, such as Arctic climates or flash freezers, Aeroshell 7 is recommended. This microgel thickened grease with synthetic oil is rated for use to -73 Celsius. Another example is heavily loaded applications, where Mobilith SHC 220 is used to satisfy the higher viscosity needs of roller bearings. To summarize, Mobile Polyrex EM covers a wide range of speeds and temperatures. In extreme cases, specialized greases are available.
Okay, so now we know what grease is comprised of and the kinds of grease available. Let's now talk about exactly what is grease incompatibility and the problems that can arise from that.
As mentioned, greases are made of multiple components to achieve an expected performance. Mixing greases of different types can create an overly thick mixture, which will not flow or channel, or can soften to the point the grease does not stay in place. Since both of these scenarios yield lower performance than the original grease, mixing of different greases is not recommended.
Okay, great information. It's good to know that something like incompatibility of greases can cause damage to a motor. Another thing that can cause damage to a motor is when not enough grease or too much grease is applied to a motor. Too little or too much, kind of like the story of Goldilocks and the Three Bears, it has to be just right. I like to call this the Goldilocks zone. So what do we need to do to make sure we stay in that Goldilocks zone when greasing a motor? How do we know when to re-grease and how much to apply?
I like this Goldilocks zone. Generally, grease should fill 30% of the empty space inside the bearing. Too much grease leads to excessive churning, which creates excessive temperatures. Too little grease and lubricating oils can be depleted, allowing metal-on-metal contact. Next is how often to lubricate. Higher speeds, higher temperature, larger bearings, dirty environments, all require shortened relubrication intervals. Lower speeds, moderate ambient temperatures, partial duty operation, and clean environments can go extended time between relubrication. While grease is somewhat forgiving, there is an appropriate time and amount of grease to relubricate a bearing. During plant final assembly, a specified quantity of Polyrex is added to the grease channel based on the frame size and bearing size. This ensures the motor is ready for use and that subsequent relubrication effectively applies new grease into the bearing. End users can then follow the MN416 installation and maintenance manual, which provides time interval and grease amounts needed based on the application.
Now, let's turn our attention to the bearings, the things actually being lubricated. We have open bearings, but there are also sealed for life bearings. We all assume that open bearings will need to be re-greased periodically. But what about sealed bearings?
Greases have improved over time. Modern greases can provide tens of thousands of hours of life in many environments. To mitigate overgreasing or undergreasing while avoiding costs and downtime associated with relubrication, many applications have moved to grease for life or sealed for life designs. These bearings have a seal on each side of the bearing, keeping contamination out and clean grease in. When applications or environments are extreme enough to exceed the limits of sealed bearings, motors are equipped with in-plate grease channels along with open bearings, allowing fresh grease to be added to the bearing over time.
So, what are some things to consider after all this?
Are you using the correct grease in your motors? Polyrex EM covers a wide range of applications and environments. However, specialty greases are available when needed. Have you been re-greasing a motor when it wasn't needed? Maybe your application is suitable for sealed for life construction. How do you know if fresh grease is reaching the bearings when you relubricate? Remember, new motors have grease channels filled during manufacturing. So if you follow the proper intervals and amounts, fresh grease is being pushed into the bearings during a re-greasing cycle. It is not necessary to see the old grease come out while adding new grease. However, if the motor is older and you are not sure of its prior usage, the best thing to do is to inspect the bearings and grease channels before the motor enters service.
Okay, Ed, thank you for your time today. It's been very informative.
My pleasure, Mac. Thanks for having me.
So, let's summarize what we covered today. First, we talked about the grease itself and how it is composed of oil, thickeners, and additives. And also the different types of grease, our standard Polyrex EM, high temperature and low temperature greases. Which one you will use will depend on the ambient temperature of the environment. Second, we discussed grease incompatibility and how it is not recommended to mix greases as their components may not mix well together, causing lower performance of the grease and possibly causing the grease to not stay in place. We then looked at how much and how often to apply the grease, staying in what we call the Goldilocks zone of just right. Too much grease is just as bad as too little grease, and we discussed how higher speeds, high temperatures, dirty environments, and larger bearings can all affect the re-greasing interval. Please refer to the MN416 that comes with every Ballot Reliance motor to determine proper intervals. And lastly, we looked at the bearings themselves and focused our attention on sealed for life bearings and their benefits. I hope you have enjoyed this latest session of ABB Motors Explained. I'm Mac McGee, and as always, be safe, and we'll see you next time.